Good morning, 7th grade. Mr. Hale here. I hope you and your family are healthy and safe. Today, in our final lesson of this 2-week period, we're going to talk about complex dependent probability. How is this different from what we've talked about before? Well, we started out with simple independent probability. And then in our previous lesson, we talked about complex independent probability. So the change today is that we're going to talk about dependent probability. If you think back to our previous lesson, complex probability means many things are happening. We're tossing a coin multiple times, or we're drawing multiple colored marbles out of a cup. Dependent means that what has happened previously somehow changes what's happening now. The easiest way to describe dependent probability, given the tools and contexts that we've previously used, is a cup full of colored cubes. So a dependent probability situation would be you reach into that cup of cubes, you pull out, say, a blue, and then instead of putting it back in the cup, you set that cube off to the side. Now, there's one fewer cube in the cup, which means the denominator of our fraction will change, which means our numbers will change. Let's go through an example or 5. Okay, so we have a cup of colored cubes: red, blue, green, yellow, and white. There are 8 red, 5 blue, 4 green, 2 yellow, 1 white. 8 plus 5 is 13, plus 4 is 17, plus 2 is 19, plus 1 is 20. So there's a total of 20 colored cubes in this particular cup. What's the probability of selecting a red? Well, we have 8 reds in the cup, so that's going to be our numerator. And then we have a total of 20. So 8 over 20. That fraction can, of course, be simplified. Both 8 and 20 can be divided by 4. 8 divided by 4 is 2, and 20 divided by 4 is 5. So the probability of selecting a red from a totally full cup is 2/5. What is the probability of drawing a red twice in a row if you put the red you choose first back in the cup? This is a throwback to our previous lesson. This is an independent situation. We're going to draw a red out of the cup. We're going to put that red back in, shake the cup, pull a red out again. So the total number of cubes in the cup is always the same. This is the same thing that we talked about in our previous lesson. This is complex independent probability. When you think back, we know that the probability of drawing a red is 2/5. We put that red back in the cup, shake the cup, and then draw a red again. That means our probability hasn't changed. So the probability is again 2/5. We multiply those probabilities across. 2 times 2 is 4. 5 times 5 is 25. So the probability, if we pull a red out, put it back in, and then pull a red a second time, is 4 over 25. You might see this on some of the homework or on MathSpace as being called with replacement. They use that term because once you've pulled the first cube out of the cup, you are replacing it back into the cup. Probability with replacement means you do a thing and then you reset the situation back to the original setup. So if it asks you for with replacement, that means you're taking the thing out of the cup and then putting it back into the cup before you do the next draw. If it says without replacement, well, we'll get to that in a second. What are the odds of drawing a red 3 times in a row if the red is replaced each time it is chosen? So here's that word replaced. That means that after each draw, we are putting the cube back into the cup. So for every draw, the situation is the same. It looks like this. Well, we know that drawing a red is 2/5, and we want to do it 3 times in a row. So we're going to do 2/5 times 2/5 times 2/5. 2 times 2 times 2 is 8. 5 times 5 times 5 is 125. But we want odds. That means we're going to write it as a ratio. We're going to put winners on the right. We know there's 8 winners. And losers on the left. There's 125 total possibilities. Only 8 of them are winners. All the rest are losers. 125 minus 8 is 117. So our odds of drawing a red 3 times in a row with replacement is 117 to 8. Now, dependent probability. Dependent probability is a situation where the result of a previous occurrence changes the probability of the next occurrence. What happened before changes what's happening now. Let's look at our next problem. Once a red cube had been drawn and set aside, not put back in the cup, not replaced, it changes the probability. What is the probability of drawing a red on your second draw? So let's think about this. On our first draw, we pulled out a red. And then we set it over to the side. We don't put it back in the cup. So there were 8 reds in the cup. But now we just put one over to the side. So now there's only 7 left. And since there's only 7 reds left, that means the total number of cubes in the cup has gone down because we pulled one of them out and set it to the side. There aren't 20 in the cup anymore. Now there's only 19 in the cup. So without replacement, if we pull a red out, set that red aside, do not replace it into the cup, it changes our numbers because everything is 1 less. There's 1 less red, 1 less total. So the probability of drawing a red on the second time is now 7 over 19. Let's say you draw a red on the first go-round and set it aside, so without replacement. What is the compound probability, that's another term for complex probability, of drawing 2 reds in a row in this situation? So what we're doing here is we know that at the beginning we have 20 total marbles in the cup. We know that there are 20 total marbles in the cup. And we know that 8 of them are red. But then we pull that red out on the first draw, and we don't put it back in. We set it off to the side. So now, we know this from our previous problem, there are only 19 total cubes, and only 7 of them are red, because one of our reds is out. We multiply that together. 8 times 7 is 56. 20 times 19 is 380. Now, 56 over 380, those are both even. So 56 divided by 380, that's a little hard one. So let's see, 56 divided by 2 is going to be 28. 380 divided by 2 is 190. So those are both even. We can go farther. 56 divided by 4 is 14. 380 divided by 4 is 95. So if we divide both our numerator and our denominator by 4, we end up with 14 over 95. 5. So that is our compound or complex probability of drawing 2 reds in a row without replacement, meaning we don't put the first red, back into the cup, 14 over 95. All right, let's do this last example. We want to get blue, red, green in exactly that order. So when we start out with blue, we know there are 20 in the cup. How many of those are blue? That will be 5. I don't know why it keeps doing that line. I can't fix it if it doesn't. Then we need to look at red. Now, we've taken a blue out, and we've put that blue off to the side. We are not replacing it. We're not putting it back in the cup. So when we do our second draw, when we want to pull out a red, there are only 19 in the cup. And how many of those are red? There are 8 that are red, but it's 8 out of 19. Third draw, we've taken the blue out, put it to the side. We pulled the red out, put that to the side. Now there's 2 cubes missing. So now we're down to 18 cubes total in the cup. And how many of those are green? 4. So there's our math. Our first draw with blue is 5 out of 20. Our second draw with red is 8 out of 19. Our third draw with green is 4 out of 18. Notice this denominator has gone down by 1 each time because we're not replacing. We're setting things off to the side. Then it's just a matter of doing our math. We can actually simplify things before we do the multiplication here. 5 over 20 becomes 1/4. 8 out of 19 is going to stay the same because 19 is prime. And then 4 over 18 can become 2 over 9. Okay, hold on 1 second while I grab an eraser. I'm going to erase that stuff across the bottom and try to rewrite it without those lines. So I'm sorry, we had 1/4. We had 8 over 19. We had 2/9. Okay, then we can do our multiplication. 1 times 8 times 2 is 16. And then 4 times 9 times 19 is 684. Well, both 16 and 684 are even. So 16 divided by, let's say, 4 is 4. And 684 divided by 4 is 171. So the probability of pulling blue, then red, then green is 4 over 171 if you are not replacing the cubes whenever you pull them out. Let's move on to our next slide. Okay, this is the one we've done before. I'm not sure why we've got some things preloading, PowerPoint's being strange, but we're going to work with it. Let's say that we want to get in this cup, this is the cup we've been using in all of our previous lessons, 15 total cubes in this distribution. Let's say that we want to get red, then blue, but we're doing it this time without replacement. Once we pull out this red, we're not putting it back in the cup, we're going to set it off to the side. So for our first pull, we know there are 3 red, and we know 15 total. But then the blue, we took this red and set it off to the side. So there's no longer 15 cubes in the cup. Now there's only 14. 3 of them are blue. So then we just do our multiplication. 3 times 3 across the top is 9. 15 times 14 is 210. Now that can be simplified by 3. 9 divided by 3 is 3. 210 divided by 3 is 70. So our probability of pulling a red, then blue, without replacement is 3 over 70. Let's turn that into odds. We need to put winners on the right, losers on the left. We know there are 3 winners. Total number of results is 70. 3 of them are winners. All the rest are losers. 70 minus 3 is 67. All right, what if we want to get black, then green? So our black is going to be out of 15 because it's our first draw and the cup is full. And we know there are 5 of them. The second draw with green, there's only going to be 14 cubes in the cup because we're taking this black that we got first and setting it off to the side. There's only 14 left. How many of them are green? 1. Now let's simplify this first fraction. 5 over 15 can turn into 1/3, and then we multiply. 1 times 1 is 1. 3 times 14 is 42. So our probability of doing black and then green without replacement is 1 out of 42. Turn that into odds. There's one way to win. All the rest are losers. 42 minus 1 is, of course, 41. Okay, one more. We want to get the exact sequence blue, red, yellow. So we know that the first draw there's going to be 15 in the cup. After we pull that out, there's going to be 14 left in the cup because we're not replacing. And after we pull that out, there's going to be 13 left in the cup because the blue and the red that we pull out, we set off to the side. We don't put them back in the cup. How many of these are blue? That's going to be 3. How many of the 14 on the second draw are red? That's going to be 3. And how many of the 13 on the final draw are going to be yellow? That's going to be 1. We can simplify the blue fraction. 3/15 can be simplified to 1/5. And then we multiply. Across the top, we have 1 times 3 times 1. That's 3. And across the bottom, we have 5 times 14 times 13. That's 910. And that cannot be simplified. 3 over 910 is our probability of doing blue, then red, then yellow without replacement. Turn that into odds. There are 3 ways to win. Put that on the right. That means 910 minus 3 is the number of our losers. That's 907. Our odds are 907 to 3. All right, that's the end of the lesson. I want to jump real quick over to discard my ink. I want to jump real quick over to the packet that I've given you guys. I want to be clear about what you guys are expected to do. If you can hear my neighbor mowing his grass in the background, I apologize. So, first off, I gave you notes that many of you probably already had from before the break about measures of central tendency. I need you guys to finish this quiz so we can end that unit. Then, this is our first set of notes on probability. We talked about simple probability. I gave you the same slideshow that I put on YouTube. I need you guys to complete this worksheet about simple probability and odds. Then we talked about compound or complex probability, more than one thing happening. I need you to then fill out this piece of homework, which talks about both simple and compound probability. And then we've got this test at the end, which is the only place in this packet where dependent probability or probability without replacement comes up. You'll notice some of the things on here are crossed out. Don't do number 3. We'll talk about experimental probability next week. Don't worry about number 10. We'll talk about percentage probability next week. Don't do number 13. In about 2 weeks, we'll talk about how casinos and other places use odds to turn into money. Don't do number 17 because in the hectic nature of everything that's been happening, I forgot to update this question with the correct number of students in the 7th grade. And then don't worry about 23 to 25, the last setup at all. That's experimental probability, and we'll talk about that next week. So on that final test, you can skip 3, 10, 13, 17, and 23 through 25. You should be able to do everything else with a little bit of hard work and thinking. Do your best. Stay safe. Wash your hands. Don't touch your face. And I hope that I will see you guys very soon.